Hello, hello, hello. Welcome to another review. This will be our test number 6, chapter 10. All right. Okay, so let's see what kind of examples we are going to be challenged with for this particular exam. Question 1. Let's see. A questionnaire was given to students. The first question asked was, how stressed have you been in the last week on a scale from 0 to 10, with 0 being not stressed at all and 10 being as stressed as possible? The responses were shown in this particular table. Okay, so we have stress rating, okay, and then we have the frequency. According to what what I'm noticing in this particular table is that from the participants, 2 um, rated their stress to be 0. 1 participant rated their stress 1. 3 participants rated their stress 2. Blah, 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 blah. 29 of them uh, rated their stress 8, 17, 9, and 12, 10. So if we add the frequencies, this will be equal to the total amount of students that participated in the survey. Okay, and I think this will be question B. So we'll leave that alone for now, but let's see. Which stress rating describes the greatest number of students out of 10? Okay, so in this particular case, which stress rating describes the greatest number of students? And that seems to be rating number 8. Okay, so why is that? 29 students rated themselves with a stress level of 8. That is a lot more than the others. For question B, it says how many students responded to this rating, and that is 29 students responded to this rating. To know the number of total students, let me actually write here the total number of students that took the questionnaire. I misspelled the word total. The total number of students that completed the survey is the sum of the frequencies. So I'm going to do that with my calculator. And so 2 plus 1 plus 3 plus 12 plus 11 plus 14 plus 17 plus 24 plus 29 plus 17 plus 12, I have a total of 142 students. So if there's a question that says, what is the total number of students that participated in this questionnaire? That will be 142. Okay, let's continue. As of 2011, the following are the ages at which a country's presidents were inaugurated. 67, oh, that's a whole bunch, okay? So here we have a table where we would like to classify the number of presidents who were inaugurated whose age were between 41 and 45. Okay, so let's see. And this is going to take a little bit of time here, but let's do a few. And so here's 1, here's 2, here's 3, here's 4, 5. I get 5. I counted 5. Okay, from 46 to 50. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8. And I think I didn't count this 45 before, so I'm going to change that 5 to a 6. I missed it earlier. So this particular example just makes you really count and just kind of just pay close attention. Not necessarily a difficult question, but you must really pay attention and pay a close eye. 51 to 55. So that's 1, 2, 3, 4, 5, 6, 7. I counted 7. 56 to 60. So 1, 2. I got 2 so far. I got 3. I got 3 on that one. 61 to 65. Okay, that's 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. I counted 10. And in doing that, I think I missed a few. I definitely missed this 60 before, so I'm going to change that to a 4. So I missed this 60 right here. I believe that I also did not count this 48 because I didn't cross it out. So that 48 would have been here. So 9. And then we got 66 to 70. So that should be the rest of the ages here. 1, 2, 3, 4, 5, 6, 7, 7. I counted 7. And I think this one was already. Okay, so here we go. All right. Now to triple check that I got the right numbers. Okay, so I could count the frequencies. So in this case, if we add up, this is a symbol for adding. If I just add the frequencies, I'm just going to do that. Okay, just a little bit of symbolic representation that I'm about to add the frequencies. That will be 6 plus 9 plus 7 plus 4 plus 10 plus 7. And let's see what that's equal to. 6 plus 9 plus 7 plus 4 plus 10 plus 7. And I get 43. Let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and another 18 that will be equal to 36, 37, 38, 39, 40, 41, 42, 43, 44. I missed one. Where do you think I missed one? Maybe this 51? Maybe this 51 I actually did miss. Okay, so this one, I think I'm just going to just continue as I might have just missed one here. We get 44. Okay. All right. So just be very careful with number 2. Just pay close attention. Triple check, triple check. All right. Number 3. Students were asked, how stressed have you been in the last week on a scale from 0 to 10, with 0 being not stressed at all, not all stress, and 10 being as stressed as possible. The students' responses are shown in the frequency distribution below. Construct a histogram and a frequency polygon for the data. Okay. So it seems like stress 0. And then here we have the frequency. So this is the frequency and this is the stress rating. I think that's, yeah. Okay. So let's see which one doesn't make any sense. So let me just erase this for a moment here. Let's see which ones do not make absolutely sense. We got 0, 1. Okay, so I could tell that this one right here makes absolutely no sense because it is saying that 10 students reported a level of 0 stress. And same thing with this one, so not counting that. Now, I don't know if this is an actual rectangle here or I don't know what that is, but maybe I want to inspect this a little bit further. Rating of 1, that was close to 4. Now, I think that that's about this one doesn't make any sense. So therefore, we're going with this option right here. And then notice that 2, 5, that seems pretty close. 3, maybe 19. Yeah. Okay, so I'm good with my selection there. And then to create the polygon, okay, we're going to connect the midpoint. So we could do that. Something that looks like this. So we go connect them with straight lines. And let's see which one looks similar to what we have up here. Okay, uh, so to do this, this is 115 does not meet that requirement, so this is not it. Here is 1.5, 2.5, close enough. 3, 4, then this, up, up, up. I like this one so far. All right, but let's see the other ones. Let's see if they make, oh no, definitely not this one. And definitely not this one. So we're gonna go with this option right here. Okay. All right, so moving on. The stem and leaf plots compare the ages of 30 actors and actresses at the time they won an award. Okay, so to understand this stem and leaf plot, it is saying that in this case there is an age of 20 if I'm looking at this stem and this leaf. Okay, so there is an age of 20, there is an age of 21, there is an age of 24, there are 2 ages of 26, and there's one age of 27. To understand this stem and this leaf, there's an age of 51, there's an age of 55, there are 2 ages of 58. Okay. All right, so what is the age of the youngest actor in the award? That will be a 20-year-old, because that will be this 2 and this 0, that will be the age of 20. What is the difference between the oldest and the youngest actress to win an award? Okay, actress. Okay, so the oldest is 84 minus 20, which is equal to 64. What is the oldest age shared by 2 actors to win an award? Okay, so what is the oldest age shared by 2 actors to win an award? That would be 58. Okay, although, I wonder if they mean here, because here we have 61 and we also have another 61. Here we have 58. So I am going to say that they imply this one right here. So that will be 61. D, what differences do you observe between the 2 stem and leaf plots? What explanations can you offer? There is a higher frequency of actors in their 40s and 50s than there is actresses and a lower frequency. So he's talking about there are more actors in their 40s and 50s for men. Oh, there's definitely a lot more men. Okay, so that seems to be true. Than actresses, and a lower frequency of actors in their 20s and 30s than actresses. That is true. This could be explained by the actors being older when they win an award. There's a higher frequency of actors in their 60s. Now they have the same amount, so this cannot be it, because notice that in their 60s, there are 3 of them that are men and 3 of them are women, so there is no higher frequency between any of the 2 genders. There is a lower frequency of actors in their 40s and 50s than actresses in a higher. There is a lower frequency of. That makes no sense. The answer here is A. All right, so just watch out for that. Read everything carefully there. Okay. Don't get tripped up by the words. But I'm going to check here this on the answer choice. I'm going to check this. This has me puzzled. Okay. And I'm checking. And I guess I just have to scroll all the way down to the answer choices. So what do they mean by actors? Do they mean both men and women, or do they just mean men? So we're going to check 4C. 4C. And that is 58. So that means there were, in this particular case, they are just referring to men. So when they're saying the word actors, they're referring to just men, not both men and women. So in this case, we need to change that to a 58. All right, then. Moving on to 5. Find the mean of the following group of data items. Okay. In order to find the mean, here's the symbol, excuse me. It's going to be the sum of these numbers. So 68, then a 61, plus a 66, plus a 72. All of this divided by 1, 2, 3, 4, 5, 6. Okay, so there's 6 data items. So in that case, well, let's do the sum first. 69 plus 66 plus 68 plus 61 plus 66 plus 72. That is 402. First do the sum and then divide by 6. And we get 67. So the average also mean the average data item is 67. Find the mean for the data items in the given frequency distribution. Okay. So what this is saying is that there is 2 scores of 1, there is 5 scores of 2, 4 of 3, 3 of 4. So if you wanted to write it out, it would look like this. That is a 1. That is another 1. There are 5 fives. But that will be like 1 too many to write if I continue this particular pattern, okay? But I don't want to do that. Okay, so let's see if I can find the average, okay? So it's going to be, so we know that there is 2 1, so that will be, so the mean will be equal to, I think I need a little bit more room, so let me do that here. The mean will be equal to 1 times its frequency plus plus the number 2 times its frequency, because there are 5 2's, plus 3 times its frequency, plus 4 times its frequency, plus 5 times its frequency, plus the number 6 times its frequency, plus the number 7 times its frequency, plus the number 8 times its frequency. All of this divided by the total amount of frequencies, 2 plus 5, so that would be 2 plus 5 plus 4 plus 3 plus 3 plus 2 plus 5 plus 2. That is the total number of entries. 2 plus 5 plus 4 plus 3 plus 3 plus 2 plus 5 plus 2, and we get 26. All of this divided by 26. So the mean will be equal to whatever this sum is, divided by 26. So I'm going to use my calculator to do that. So we have, let's see if I can make this better. That will be 2, that will be 10, that will be 12, that will be another 12, that will be 15, that will be 12, this will be 35, and that will be 16. So let's find the sum of these numbers. And I encourage you to pause and just add it up with your calculator. 2 plus 10 plus 12 plus another 12 plus a 15 plus a 12 plus a 35 plus 16. And I get 114 divided by 26 and round to 3 decimal places. So I get 4.3846. And so this 6 makes that 4 into a 5. 4.385. Okay, so we found the mean. We did some with ungrouped data and we did some with group data. Notice that in this case, when I have the frequency distribution table, I did the score times the frequency, and then we add, we computed that particular sum. All right. Find the median. Okay, to find the median, we need to arrange the data from smallest to largest. So 91, 92. It seems like we got two 94s, and then a 98, and then a 99. The median will be the data item right in the middle. So notice that in this case, it seems to be like these two are right in the middle. Since those two are right in the middle, we take the average of those two scores. And it turns out that in this case is equal to 94. So let me explain. There was not one data item that splitted the data in half. In this case, it was two of them. Okay, so we take, in this case, if it is the two in the middle, we take the average of those two scores. Find the mode. To find the mode, we need to find the data item that occurs the most, the one that repeats more than the others. Well, there could be no mode. Okay, there could be no mode if all of the data items repeat exactly the same amount of times. But there could also be more than one mode. There could be two modes, there could be three modes. Let's look at this data and see what we get. I'm going to rearrange this from smallest to largest, just so that I can have some order here. So I see a 44, then I see a 48, I see 149, and I see 155. And I notice that none of these data items repeat more than the others. They all show up only once, so there is no mode. For example, if there would have been another 55, then the mode will be equal to 55. If there would have been another 33, then the modes would have been 55 and 33. Okay, but in the example that we have, since all of the data items repeat only once, therefore there is no mode. Okay. Alrighty then, moving on to number 9. Use the display of data to find the mean, median, mode, and mid-range. Okay, let's do this. Okay, let's find the, so they're telling us that there is, in this particular case, this dot right here, that the score of 10, so this would be the score, this would be the frequency, that the score of 10 shows up 3 times. The score of 11 shows up 1 time. The score of 12 shows up 5 times. The score of 13 shows up 6 times. The score of 14 shows up 1. And the score of 15 shows up 2 times. Okay. So the mean will be equal to the data item 10 shows up 3 times, plus the data item 11 shows up once, plus the data item 12 shows up 5 times, plus the data item 13 shows up 6 times, plus the data item 14 shows up once, plus the data item 15 shows up 2 times, divided by the total number of frequencies. 3 plus 1, so these are the frequencies. 3 plus 1 plus 5 plus 6 plus 1 plus 2. Okay. All right, so let's see. Well, 3 plus 1 is 4, and 6 is 10, 16, 18 data items. And then let's do this up here. So we got 30 plus 11 plus 24 plus 6 times 3 is 18. So that will be, wait, this is not 24. This is equal to 16. Plus, in this case, that will be 78 plus 14 plus 30. And so then I'm going to add and divide. So 30 plus 11 plus 60 plus 78 plus 14 plus 30. That's 223. And then I divide by 18. Therefore, the mean is equal to how many? Just 10th, 1 decimal place. We get 12.388 repeated. So therefore, this 8 turns that 3 into a 4. Okay. To find the median, again, we find the data item that is right in the middle. There is 18 items. 18 items divided by 2 is 9. We need to look at the 9th and the 10th data item and find their average. In that case, we have, well, the first 3 will be 10s. Then there is a 4. Okay, 4. 4 plus 5 is 9. So therefore, the 9th data item is 12. And then therefore, it makes the 10th. The 10th will be in this interval, which is a 13. So therefore, since the 12th item will be a 12, and the 10th will be a 13, we take the average of those two. So 25 divided by 2, which will be 12.5. Okay, it's not writing or writing pretty weird. Once again, there were 18 data items. Divided by 2 makes it 9th. Now, why did I do this? There is an even number of data items, okay? So therefore, we have to take the 2 in the middle. That's just kind of unfortunate, okay? So in this case, we said that there must be the 9th and the 10th data item. There were 3 10s and 1 11. So far we have 4. and the 5/12 makes 9. So the ninth data item is a 12. That puts us in the next interval. So therefore, the 10th item here must be a 13. And so therefore, to find the median, this is what we did to find the median. We take the average of those two scores. The mode. Well, if by inspection we see that the data item that occurs the most is the 13, there's only one of those, so therefore there's no need to separate it with a comma. And so the answer here is A. Okay. And the mid-range, to find the mid-range, we need to find the highest score minus the lowest score divided by 2. So the highest score is a 15 minus the lowest score is a 10 divided by 2. 5 divided by 2 is 2.5. Okay, let's move on to number 10. In one common system for finding a grade point average or GPA, A is equal to a 4, B is equal to a 3, C is equal to a 2, D is equal to a 1, and an F is equal to a 0. The GPA is calculated by multiplying the number of credit hours for a course and the number assigned to each grade, and then adding these products. Then divide this sum by the total number of credit hours. Because of each course grade is weighted according to the number of credits of the course, GPA is called a weighted mean. Calculate the GPA for this transcript. Okay, so this is a score of 3. This is a score of 3. Oops. This is also a score of 3. And this is a score of 2. So therefore, it says to multiply. So let's do that here. 3 times 3 is 9. 3 times 2 is 6. 3 times 4 is 12. And 2 times 5 is 10. Okay, so we multiply, and then adding these products, okay, we add these products and divide, okay, divide by the total number of credit hours. Well, that number is 3 and 4 is 5. 3 and 2 is 5. And another 5 is 10. So that will be 14 credit hours. Okay. So we add these numbers and divide by 14. So we got 9 plus 6 plus 12 plus 10. That is 37 divided by 14, which is equal to, let's see what they want us, 100th. So that is 2 decimal places. 2.6428. But because this 2 is not big enough, it's not a 5 or greater, this 2 does not make this 4 into a 5. So therefore, the GPA is 2.64. Okay. Alrighty then. Number 11, find the range. To find the range, we take the difference between the highest value or score minus the lowest score. That will be 22 minus 14, which is equal to 8. Number 12. A group of data items and their mean are given. Find the deviation from the mean for each of these data items, and then find the sums of the deviations in part A. Okay, so let's see. So what I mean by find the deviation from the mean of each data item, they want to do this, okay? They want to say 96 minus 24, and they want to square that number, okay? So that was for the first data item. That is what I'm going to type here. So let's see, 94 or 96, because that is the mean. Actually, no, let me take that back. Let me take that back. I want to do it like this. It will be 24 minus 96 quantity squared, even though it won't make a difference, but I want to write it correctly. And that is 5184. Okay. And then we have to do 40 minus, I forgot the minus 96 quantity square. And then we're going to do 56 minus 96 quantity square. Then we're going to do 96 minus 96 quantity square. Then we're going to do 144 minus 96 quantity square. And then we're going to do 216 minus 96 quantity square. Okay. For part B, they want us to find the sum. But let's first find, okay, so this is what basically they want us to do. Okay. All right. In part B. But let's go ahead and find these differences raised to the second power. 40 minus 96 quantity square, I get 31, 36. 56 minus 96 quantity square, that is 1600. That will be 0. 144 minus 96 quantity square, 2304. 216 minus 96 quantity square, 14400. And then they're asking us to find the sum of these numbers. So 51, 84 plus 31, 36 plus 1600 plus 0, 2304 plus 14400. I get, in this case, 26,624. Okay. All right then. 13. Okay, so let me just double check that that's how they wanted to approach this particular example. Let's see, 12. But that was 12, no? Then, wait, they didn't do that? Oh, no. Oh, okay. So let's go back here and, okay. All right. So I'm getting ahead of myself because I know what, what is required of us to do in number 13. Okay. However, in this case, it seems like they didn't want us to do this square. Okay, so they just want us to just not do that. Okay, so we're gonna have to change these numbers and this sum, which I don't really like that, but that's okay. That's just the way this example is. Okay, so we got 24, that will be negative 76. Then we got negative 56. Then we got negative 40 here. Then we got 0. 144 minus 96, we got 48. And 216 minus 96, that's equal to 120. And then they want us to add these numbers. So negative 76 minus 56 minus 40 plus 48 plus 120, and I get negative 4. Oh, I think, oh, I messed up over here. 24 minus 96 is 72. So therefore, this answer right here will be equal to 0. Okay, all right. Let's do something similar to that for number 13. To find the standard deviation, okay, we must first find the mean, okay? Once we find the mean, then we need to find a series of numbers that will look like this. It will be the data item minus the mean quantity squared. And we're going to do that for each one of these entries. And then we're going to have to divide. So we're going to find a sum, okay? And then we're going to do a division here by n minus 1. And then all of this will be the square root, okay? But let's go ahead and tackle this one step at a time, okay? I'm going to rearrange. Oh, actually, it's only 16. So 1, 2, 3, 1, 2, 3. There are 4 16s. And there are, actually, let me write it this way. 16 times its frequency plus 20 times its frequency. 1, 2, 3, 4. This divided by 8, because there's 8 data items. So therefore, we got 16 times 4 plus 20 times 4, which is 144, divided by 8, and we get 18. So then we will have to do this. 16 minus 18 quantity square, and we have to do that 1, 2, 3, 4 times. But since we know we're doing that same operation 4 times, I'm just going to stick a 4 there. Plus, same idea, we're going to do 20 minus 18 quantity square, also 4 times, okay? All of this will be divided by 18 minus 1, okay? So let's do that. So we got, well, that would be 4. This will be negative 2. And negative 2 squared, that will be 4. Plus, oops, I forgot the 4. Plus 4, that will be 2 quantity squared, which is also 4, divided by 17. This will be equal to 8 plus 8, which is equal to 16 divided by 17. Okay. All right. And then 16 divided by 17. I get 0.9411. I think I'm going to have to pause this real quick. No, that's not what I meant to do. Okay, so I made a critical mistake here because I don't know why I put 18 there. That should have been 8. The number of data items minus 1. Okay, so that was really, really funky. Divided by 7. That was really funky. So again, the number of data items minus 1 and minus 1. I don't know why I put 18. Okay, so 16 divided by 7. And in this case, we have 2.2287. And then we have to take the square root of this number. But something is not making sense. Okay, so somebody really needs to double check this because I forgot that 4 times 4 is 16, and that would be 16, making that 32. Oh, Jesus, Lord Lanta. I think I might need a break here. Okay, 32 times divided by 7, and that makes that number 4.57 and 1/4, and a lot more decimals. And the square root of this number is equal to 2.138. And because we want 2 decimal places, that 3 becomes a 4. Well, I think for this example, I hope that you being more careful than I was, because apparently I was not being careful, and that just made the example more complicated. Okay, so compute the following mean, range, and standard deviation. For, oh wow, okay. All right. So let's see if we can let, let's look at the first one and then see if we could use technology for the other 2 examples, okay? All right, let's find the mean. The mean is going to be equal to 26 plus 30 plus 34 plus 38 plus 42 plus 46 plus 50, all of that divided by 1, 2, 3, 4, 5, 6, 7. Okay, so let's do the sum and then the division. 26 plus 30 plus 34 plus 38 plus 42 plus 46 plus 50, that's 266 divided by 7, we get 38. Okay, so the mean is equal to 38. The range is 50 minus 26, which is equal to 24. The standard deviation, all right, let's do that one more time, okay? That is going to be 26 minus 38, quantity square, plus 30 minus 38, quantity square, plus 34 minus 38, quantity square, plus 42 minus 38, quantity square, plus 46 minus 38, quantity square, plus 50 minus 38, quantity square. Everything here divided by 7 minus 1, which is equal to 6. And then we'll take the square root of all that. All right, so let's use our calculators to do this. Let's see, so that will be the square root. Hopefully I can fit all of this here. Everything divided by 6. And here we go. 26 minus 38, that's 12, quantity squared, that will be 144. Plus, that will be 8. 8 squared, that will be 64. This will be negative 4. Negative 4 squared, that will be 16. That will be negative, well, no, that will be positive 4. Positive 4 squared, that will be another 16. I'm running out of room. And in this case, we got 46 minus 38. That's 8. That will be 64. And then 50 minus 38, that's 12. That's plus 144. Okay, so now let's go ahead and find that sum. Find that sum, divide by 6, and then we'll take the square root. So 2 times 144 plus 2 times 64 plus 2 times 16 divided by 6, so that will be 448. And then 448 divided by 6, take the square root of that, so we get the square root of 74.666 repeated, and then the square root of that, okay, I get here 8.64. 8.64. Okay. Well, that, I hope that that's going to take you way too long to do that by hand. So maybe we can get away with using a little bit of technology. Okay. So first, I'm going to write these numbers down on a piece of paper. 26, 28, 30, 38, 46, 48, 50. The range will be 50 minus 26, which is also again equal to 24. But let's see if we can find the mean and the standard deviation using technology. So here we go to Stat, Edit, and then we'll type in our information: 26, 28, 30, 38, 46, 48, and 50. Then we'll press Stat, go over to Cal, and you press option 1. So in this case, again, I'm looking at this symbol right here, the X with the bar on top of it, that's the mean. That will be equal to 38. And the standard deviation that we want in this case is the one with the S, okay? And so therefore, let me just write that down. We have 38, and the standard deviation is 10.13. So going back here, we have that was equal to 38 with a standard deviation of 10.13. Let's do that for sample C. Okay, so let me just write that down. We have 26, 26, 26, 38, 50, 50, 50. Let me find the range. That will be 50 minus 26 is equal to 24. Let's type in the data into the calculator. So let's go to Stat, Edit, and here we type 26, 26, 26, 38, 50, 50, and another 50. Okay, so then we press stat, cal, and you press 1. In this case, the mean is once again 38, and the standard deviation is the one with the S. This is the one we want, which in this case will be equal to 12. Okay, so here we have 38, and this will be equal to 12. Let's just triple check the first set of data. Okay, we had a 26, 30, 34, 38, 42, 46, 50. Stat, edit, 26, 30, 34, 38, 42, 46, and 50. Stat, cal, 1, enter. And we get the same information that we had before. But the mean was equal to 38 with a standard deviation of, again, 8.64. Okay, that's exactly what we got by doing this computation by hand. So, in which of the following ways are the samples alike? Well, they all have the same mean. I think that was pretty obvious. They also have the same range. Okay, so let's see. Oh, there's an option for mean and range. Okay, that was good. So make sure you look at all the options. In which way are the samples different? Well, the standard deviations were different. Okay, the standard deviations were different. What, all of that to answer those two simple questions? Oh no, that is one very picky question. That is one very picky question. Okay, so let's see. 15. Describe what the standard deviation reveals about the data set. The standard deviation reveals the total spread of a data set. Okay, it doesn't talk about the average. It doesn't reveal the level of variation. It reveals the total spread. Oh, the level of variation. I think this will be the range. Okay, we're gonna check on this. Let's see. 15. Yes, the level of variation, yes. Okay. All right. 16. The total spread, that will be the range. This will be the range. And the average, this is the mean. Okay. Okay, so the scores on the test are normally distributed with a mean of 100 and a standard deviation of 20. What is the score that is one standard deviation above the mean? Okay, so the idea here, okay, this is the mean and this is the standard deviation. Okay, the idea is that we got some graph that looks like this. Okay, some kind of bell-shaped graph that looks something like this. There is the mean will be right here, right down the middle. This will be the mean. To the right of it will be one standard deviation away, and to the left of it will also be one standard deviation away. Then we have two standard deviations away to the left and to the right. And eventually, over here, three standard deviations to the left and to the right. So this is kind of something that looks like this. Okay. So if the mean is 100 and the standard deviation is 20, that means that this score right here will be 120, and this one right here will be 80. In other words, 100 plus and minus 20. So a score of 120 is one standard deviation. So therefore, for example, here we can write 121. Okay. We want it to be above. I think they mean to say here 120. Let's just triple check. They want to say here 120. Yes. All right. So let's see. A test score, the test scores on a test are normally distributed. What that means is that the graph looks like some sort of bell-shaped graph. Okay. I could do better than that. Something that looks like this, like some sort of bell. This is the mean, and this is the standard deviation. What is the score that is one standard deviation above the mean? Again, if this is the mean plus the standard deviation, this is equal to 144. Again, it could be, so going back to this idea here, this would be plus 20 plus another 20 plus another 20. In this case, that will be minus 20 minus another 20 minus another 20. Okay. So a score 1 standard deviation above the mean is 120. A score 2 standard deviations above the mean will be 140. And a score 3 standard deviations above from the mean will be 160. The figure illustrates a normal distribution for the prices paid for a particular model of a new car. The mean is 12,000 and the standard deviation is 500. So here you see plus 1 standard deviations, plus 2 standard deviations, plus 3 standard deviations. What percentage of buyers paid between 10,050 and 12,000? Okay. So what percentage of buyers are in this range? Okay. So we'll notice that this particular curve is symmetrical. So the same amount to the left, the same amount to the right. So if from here to here is 99.7%, then from here to here must be half of that. 99.7 divided by 2, we get 49.85%. 49.85%. Okay. Again, when we're looking from here to here, we know that from here to here, that is 99.7% of the buyers. We want half of that. So therefore we divide by 2 and we get 49.85. 19. Scores on a dental anxiety scale range from 0 to 30. The scores are normally distributed with a mean of 21 and a standard deviation of 4. Okay, so we have a mean that is equal to 21 and a standard deviation that is equal to 4. Find the C-score for the given score on this dental anxiety. So the C-score is given by, in this case, the score minus the mean divided by the standard deviation. Let me just triple check on that. Oops. Just gotta triple check on. I just wanted to triple check on that. So we're good there. How do we do this? Okay, so the Z-score, there is a table. Okay, there is a table. And let me bring up the table. So let me pause. I'm going to bring up the table and then we'll go ahead and do, well, let me do this computation first, okay? So we're saying that 28 minus 21 divided by 4. Well, 28 minus 21 is 7 divided by 4. That's going to be equal to 1.75. This number, all right, we're going to look it up on a table. So let me go ahead and bring that up. So let me go ahead and click pause for a second. I will look for the table. You should also have this table with you. Okay, remember that the score, the Z-score that we got was 1.75. So you should see something, something similar. This is from another textbook, but it's the same area under the normal curve. So since we found that number to be 1.75, here we go look at the Z-score 1.7, 1.700, 1.71, 1.72, 1.75, and that is 0.4599. Okay. So the answer that we want to write here is 0.4599. Okay. Again, that table should be available to you on your exam. All right, let's look at what's going on here. Number 20, our last example. A data set that is normally distributed with a mean of 100 and a standard deviation of 40. Find the data item in this distribution that corresponds to the following Z-score. Okay, so, okay, the data item. Okay, so Z is equal to, we're looking for the data item. Okay, so we're going to do a little bit of algebra here. The data item is, the Z-score is -7. So we're looking for the data score minus the mean. That's 800. And the standard deviation is 40. In this case, we're going to multiply by 40 on both sides because this 40 will go away. That will be -270. Wait. What is going on here? Yeah, 280. What am I saying? -280. And in this case, we add 800. Adding 800 will isolate the data score. And in this case, we get that the data score must have been 520. Okay. All righty then. Let's just triple check on that. So we got, yeah, we got the last numbers right. Okay, so I wish you well on this exam. I hope that I was able to make everything as clear as possible in one sitting. I hope that you can use this review to help you navigate through this exam and make a good score. Hopefully you find it as useful as possible. My apologies for the silly mistakes that we made here and there. Okay. By the way, we could do number 13 also with the calculator, and let's just do that real quick. Okay. So there were 1, 2, 3, 4 16s and 4 20s. All right. So let's do that real quick. I just want to show you that we can also do that with the calculator. So we had, I'm just going to type it 20, 20, 20. There were 4 20s and 4 16s. Okay, I got all my data in there. And then I go ahead and say stat count 1, and then bam, there it is. Okay, and that would have saved us a whole lot of headache. Notice that the standard deviation, all right, is the same with the calculator and what we found by computation. So that you can save yourself a lot of headaches. Okay, notice that in this case, it also gives you the mean. So that's, if you need to answer some kind of questions like that, you could use the calculator to find the mean. I think overall, this wasn't that bad. So my apologies for the video being too long, but hopefully you'll find it useful and you get a good score on this test. Okay. Once again, thank you, and I'll see you next time. Bye bye. And now I need to close.